I'm going to start it now. Okay, back to the top again. Won't take long. If you see a diagram without any lengths shown to you, you're obviously meant to calculate them. So 8 subtract this 2 must give you 6, and 6 take away this 3 must give you 3 for this part. So it's very straightforward areas and perimeters. Done. Surface area of a cuboid, very, very, very badly done. Very badly done. Depressingly badly done. Surface area is not a volume. It's not 3 times 6 times 1. That's a volume. But the surface area is, work out the area of the 6 faces that make up that cuboid. At the front I've got a 3 by 1, and I've got 2 of them because there's one on the back as well. Down the side I've got a 6 by 1 rectangle, but I've got 2 of them because I've got this one as well to the side opposite him, and I've got a 6 by 3 on the top and a 6 by 3 underneath, 2 of them. So you get a mark for working out each little bit, and a final mark for doubling up and getting the total correct. 4 marks. Many of you didn't get 1, which means you didn't revise. Question 3, generally done okay by some of you. You will know that a volume is the area of the front face multiplied by the depth as it goes into the page. Well, the front face is a triangle, half base times height. Get your answer if you want to, and then you can multiply by 12, or do it one step. Half base times height times 12, 180 centimeters cubed with a unit. 2 marks. This is the more challenging one. There we go, you can see it in one go. This is the surface area of this prism. Now again, if you see missing lengths, you better put down lengths next to them, otherwise you're going to miss something out. So that's a 6, matches that. That's an 8, matches that. And that is a 10 because it matches that. And the 12's are given. Now we're good to go. I can see 2 triangular faces which are identical. I can see an 8 by 12 by itself. I can see a 6 by 12 by itself, and I can see a 12 by 10 at the front. So I've got 5 different faces. All right. So I've got a half base times height for the triangle. There it is, and I've got 2 of them. And like I said before, I've got a rectangle 12 by 10 there. I've got a 12 by 8, that one, and a little 12 by 6, that one. So there's 5 faces, there they are. Work them out correctly. I sort of allowed up to 2 marks for that. But everything you got wrong, you know, you tend to lose a mark if you get things wrong. So I allowed about 3 marks for that. Not difficult. Again, you should be taking notes down. If you don't, hey, it's up to you. Now let me introduce you to some careful reading. That goes for all of you, without exception. Describe fully the transformation which maps Q onto P, not P onto Q. It's Q back down to P. Well, it's clearly an enlargement, 1 mark. Don't have the word enlarged, please. That's not a transformation. Call an enlargement. And since we're going from Q down to P, it's half size, scale factor of half. And if you pick up your ruler and run through the 2 corresponding vertices, you just need a couple. I could run it through that one as well. It will meet at 0, 0, the origin. So there's your 3 marks. Enlargement, scale factor 1/2, about the origin. All right, 3 marks just for that, but that's the way GCSE is marked. Question 6, badly done. Not everyone knew what the line y equals -1 looks like. Well, there it is. Draw the image of that in the line y equals 1. So if you draw it in, your eyes have got less chance of skipping over an entire row of boxes. So that's the correct position of it. So that will get you a mark. It's a straightforward reflection. Then you've got to translate this by 5 across 7 up. Okay, the phone's ringing, it's annoying me, but anyway. So 5 across 7 up. So be very careful. Once you get this right, you go 1, 2, 3, 4, 5, and jump up 7. 1, 2, 3, 4, 5, 6, 7. Now I deliberately chose this as a leading point because I know once that arrives at that position, I just want to draw back and get the rest of the triangle in place. Yeah, all you need to do is translate one single point. Then having squared paper in front of you, it's easy to copy in the rest of it. All right, so 4 squares back, 4 squares back, 2 squares down, 2 squares down. Then you have to join the ends, and that's it. 2 marks, grade 5 GCSE. This is what grade 7 looks like when it comes to enlargements. All right. Again, very few people got any marks at all. Maybe you didn't reach that far in your studies, or you didn't revise it, or you're too busy being locked down playing Fortnite or whatever. So I've got an enlarged triangle A, this little one here, by a scale factor of -2. So straight away I know it's going to be twice as big, but it's going to flip the other way because it's a negative scale enlargement. The centre is specified as -1, -1 right there. So the very first thing you do is put a little mark by -1, -1, drawing the rays all the way through to the edge of the grid. There they are. And now you're going to have to work out what ×2 looks like and what flipped the other way looks like. So here I have a height of 3, there's my height of 6. Here I have a base of 1, here I have a base of 2. And you just join the ends. Don't come over here, please don't do that. It flips the other way. And many of you have done this in class. But here it is, 3 marks, grade 7. This is a negative scale enlargement through a given centre, all right? Now, if it was a scale factor 2, the rays would come down here somewhere off the page, wouldn't they? They come over here and it'll be a big upside down triangle. No, it's negative scale enlargement. So it tracks back through the original centre of enlargement given. Then obviously you've got to count the squares to make sure the heights and the base is correct and that it's facing around the other way. 3 marks, it's grade 7. Many of you gave me your life story for question 8. You didn't need to give me your life story. State means just give the rule. Don't write, I see 2 14s and the lengths are all the same and the 25. No, this is called a side angle side rule, SAS rule. That's all there is to it, okay? These are the 2 corresponding sides, or rather matching sides. These are 2 matching sides, and the 25 is the included angle between the 2 sides. All you had to say was SAS. You didn't even have to write side angle side. Next one, SSS. All sides are the same. Don't write me a big long story over here. It's a mark. It's a side rule. And if you remember the classwork, that's all we did when we did congruency in class during one of the Zoom lessons. You didn't give a long drawn out story. You just quoted the rule that confirms that the pair of triangles presented are congruent. That's it. This one is an ASA rule, or as some of you put down, AAS rule, which is okay, because if you got these 2 angles, 80 and 25, then the third one's got to be 75. If that's 80 and 25, that's got to be 75. And look what you got. You got an angle, a side, and an angle. Here, the side is the included part. What do we have on over here? We have a 75, a side, and a 25, and the side is included. So I would call that ASA. You might like to call it AAS. It doesn't matter. The fact that you got these 2 angles means that the third one, because it's a triangle, has to be the same for each one. So that's okay. So I gave ticks for AAS and ASA. But I didn't read all the story you gave me, it's just too much. And behold, section B is to follow. It will be a more intense video next time we meet up, which I think is Wednesday, 2 o'clock. If I'm not mistaken, we'll do that really carefully. There's a lot of rich, deep stuff, a lot of stuff you've forgotten, a lot of misread of the question, or rather misinterpretation of some of the diagrams, and you're inventing maths that just doesn't fit with the questions that were presented. So